All right, so we're continuing where we left off in section 6.2. And the reason why I made the break there, I've had longer videos, but the reason why I made the break where I did was up until now, in this entire section, we haven't found any answers to any questions. There was never a question where, you start here, you work, do some work, and you find something. Well, I guess if they straight up asked us what f of f inverse was, and we said, oh, the answer is x, and you typed in x, that would be, finding the answer to a question. But, they said verify something. How would they even word that on the computer? Verify this as a function. Well, the way they'd word it is they'd ask you to do this, and you type in x, but I don't know. These don't really feel like questions that start with or problems that start with a question and finish with an answer. They're more subtle than that in, testing opportunities or quizzing opportunities. You could say, well, I verified it because, I know they cancel. That's not true. You should be able to verify something, but, I want to get to questions where you're not just verifying or answering yes or no, this is or this is not an inverse function. I'm talking about finding something, finding the inverse of an equation. So I will say this. We spent a little bit of time talking about one-to-one functions. There aren't any trick questions. When they give you a function, it will be a one-to-one function. Now, sometimes they'll explain, they'll change the domain to force it to be a one-to-one function. But my point is, it'll be a one-to-one function. So we don't have to worry about that. So remember, one-to-one functions have inverses, but they want you to find it. All right, so they start with this idea. They're always going to give you this f of x equals, and you want to change it to y equals, and then interchange x and y. Now, we've seen interchanging x and y before on this whole topic, back when they were ordered pairs. But I decided I'd go through the process here. So here's the process. I'll do it in red. If that's the function you have, you're going to change the to the chapter 2 notation instead of this function notation. And then I like to draw this little wall right here, because normally when I draw an equation under an equation, under an equation, under an equation, I'm saying that those are the same or they're equivalent. Now I'm going to transform this equation, and something happened at that wall. Above this wall, I'm talking about f of x. Below this little wall, I'm talking about f inverse of x. I'm talking about the new function, because when I switch them around, x and y, it's no longer the original function. Now it's the inverse function. All right, and then the only thing left to do now is to solve for y. So to solve for y, I'll add 5. Let's divide both sides by 3, but also at the same time put the y on this side of the equal sign. And I'm kind of done, but the only thing left is, let's go ahead and spell out that I started with f and I finish with f inverse. So the idea is I found the function that will cancel this function. This has a plus 5, or minus 5, this has a plus 5, this has a 3, this has a times 3, this has a divided by 3, and they're all in the right places. So that's how you find the inverse. But this process, don't confuse the process with the answer. This was the question. This was the kind of predictable answer, but just make sure you have everything in the right places. I'll put it this way. If there was a multiple choice question, one of the wrong choices would be some that also had a divided by 3, also had a plus 5, but not in the right order. So know the process. But I'm going to say this process is more important than you think, more important than you can imagine. and finding inverse functions. So let's see what they did. So in this question, they took the original problem. You can't see it. Right? Y equals 3x minus 5. But they wrote it this way, with x where the y is, y where the x is. So there's that step that we had. And hopefully you see how it came about. And they went and solved for it, and they got the answer. They wrote, instead of divided by 3, they wrote times 1/3, but you get the idea. And they even did that last little step where they replaced y with f inverse. All right, same thing I did by hand. No surprise, they're going to have you graph it, and if you do graph it, you'll notice that there are mirror images on this on the line y equals x. And and they test it sometimes. This is the check. A checking, again, is one of those things you can't really put that on a test. I guess you could. They could ask you to check it, and you know you're going to get x, but you know you're going to get x. So the check isn't really much of a surprise. All right, I think this question is going to test us pretty thoroughly because of all of the things they could ask. All right, so here's the question. And you have no idea yet how important the process is, because the process is going to tell us, going to reveal a lot. All right. So, well, let's see what they did. All right. So they did, I'm just going to kind of go through it, but I'm going to do this one by hand too. They went through it, changing this, and then here's where that little wave would come. And they're going to change this y into an x, and they have two x's. Both of them get changed into y's. Go through the process of solving for y. That allows you to answer this question. And it might, well, they had to put this there, I guess. I don't know why they put that there. I do know why they put that there, but it doesn't really stand out as anything very important right now. But let's go through that one. So I have it queued up right here, and I am not going to disagree with them. I would do exactly the same thing. Y equals x plus 1 over x minus 2. But I don't know if you remember, but I kind of skimmed past this thing about domain and range, because we have a better strategy. And here it is. I'm going to write down the domain and range above this line and below this line. Remember, above the line is f of x, and below the line is f inverse. And what the book said was accurate. The domain of one is the range of the other, and vice versa. All right. So, just doing the mechanics of this, but let's stop on this. All right, the domain of the original function is something we've done quite a bit. If x is 0, I'm sorry, if the denominator is 0, I get x equals, if the denominator is 2, or if x is 2, I said it right. If the denominator is 0, it would be undefined, so if x, that happens when x is 2, so x is not equal to 2. I don't know if you realize how monumental that step is, because remember what we do on the other side of this line. We change x to y. So that means the range of the inverse function is y is not equal to 2, because the domain of one is the range of the other. Now this next part of this, I don't know, it kind of depends on how well you remember things from chapter 5. And that is, is it obvious what the range is? It probably isn't. If we graphed this, there would be a horizontal asymptote, and it would be at y equals 1. And actually, it doesn't really matter how obvious that is. because I have a way of finding the range, and that is by finding the domain of the inverse function. I don't know what that is, but I could go this direction where if I knew the domain, I could find the range. But I shouldn't just skip over this. There is one thing this cannot equal. 1. This cannot equal 1. I should be looking here. Why cannot equal 1? Why do I make that claim so boldly? Well, for a fraction to equal 1, the numerator has to equal to the denominator, and x plus 1 is never going to equal x minus 2. They just can't equal each other. It's also where the horizontal asymptote is. And the graph never crosses or touches this particular horizontal asymptote. So y is not equal to 1 is the range, and that means I'm predicting that x is not equal to 1 is going to be the domain of the inverse function. Predicting the domain is not really much of a feat because the domain just kind of lands in your lap when you do the problem. All right, so I just wanted to mention that this is something that pretty much every student does when they're doing the process, so they're ready to answer any question that might come their way, like what is the range of the inverse function, what is the domain of the inverse function, what is the domain of the original function, the range of the original function, all of that just kind of reveals itself. All right, I'm going to cross multiply. I'll get xy minus 2x is equal to y plus 1. I want a y side and an x side. So just kind of doing some rearranging. Factor out the y. Divide. And I will get, one more step. Change it to the other notation, f inverse 2x plus 1 over x minus 1. And you might have noticed that now is when the author said, oh, x is not equal to 1. When you're talking about x not equaling something, you are talking about the domain. But the domain of what? The domain of the inverse function because I'm below my wavy line. I got this after I switched the x and y. So coming back here, let's say I didn't know what the range was by asymptotes. I could calculate the domain and feed the range, or the range would predict the domain. So in a problem where they're just asking you domain and range, you could figure it out really quickly, or you could cut to the end and figure it out. But we know we can do that. So that's the problem they already did earlier. Just, I don't know, it has a different flow and kind of pace to it when you do it by hand. So I really believe you should, try that. This whole idea of checking it, really not very exciting. You go through the process of checking it, and what happens every time is you get X. All we're doing is verifying. And don't get me wrong, verifications are a big deal in, say, calculus, verifications, proofs in a geometry class. All of those things are important, but they just don't test well online. So, in other words, if they gave you a question like this, you'd say, oh, I know the answer is going to be X because that's what inverse functions do. If we didn't know they were inverse functions, then this might be a surprise, but we know they're inverse functions, we're just verifying it. And they did it again. All right. Why all that stuff about one-to-one functions? Well, you should know the graph of this function. It's y equals x squared shifted up 1. And look at it. It fails the vertical line test. So they gave us this little caveat here where they said, you know what? We're going to get rid of this and just start the function at 0. And yes, you can do that. You can say, you know what, I'm going to restrict the domain. And if you restrict the domain, suddenly this thing that failed the vertical line test is just this little piece that passes the vertical line test. So just to be clear, there's a difference between just saying this and giving you the entire parabola and saying x is greater than 0 and just restricting half of it. That's what they're doing. By the way, they could have said x is less than 0 and that would have given you the other half, but restricting the domain sometimes is necessary to make sure the function is one-to-one. And if you do that, you can go through the process of finding the inverse. And checking it. All right, so nothing terribly surprising there, but just see how that works. This is the original function. This is the inverse of it. By the way, it could have gone the other way around. If we'd started with this function, this would have been the inverse. They're reflective or symmetrical about the line y equals x. And that is the rest of section 6.2, inverses. Now, if you look at all of this and you say, rightly so, what does any of this have to do with the topic at hand, exponential and logarithmic functions? Well, you have to watch those videos to find out, or read the book or do the homework, all right? But we didn't have any. They haven't introduced those functions yet. But let me just say it. Exponential functions and logarithm functions are one-to-one, and they're inverses of each other. That's the message that, or I guess that's the reason for the packaging and the order of this being in section 6.2. All right, so that's the last part of section 6.2.